And the first lava formation I'm going to show you guys is this one. This is called Tellez here. Very thin strings of lava that are created during natural eruptions. If the lava falls over an edge or gets caught by strong winds, these are very difficult to find in nature because they are extremely fragile. They usually break apart very quickly after forming. And here in Iceland, they are called Nornahár, which translates to witches here. And as soon as the lava starts flowing into the room, it begins to release the heat very quickly. And you can see how the lava is cooling down, because the more heat it releases, the darker the lava appears. And already up here, it looks like the lava has stopped flowing. But further down, you can see that there is still more lava accumulating. So what's happened here is that the lava on the surface has already cooled down enough to form a solid crust. And lava is actually a very good insulator. So this thin crust on the surface insulates the lava in the middle of the channel, keeping it hot molten liquid. So there is still lava flowing inside here and accumulating further down. And I've also brought with me some ice, so I can show you what happens if we cool down the lava very quickly. Because if lava cools down quickly, it's not able to crystallize into rocks. So instead, it becomes what it's most made of. And this basalt lava is around 47% silica. So if you put ice on it, it should transform into volcanic glass. And we also see that the lava is bubbling a little bit here. And this is caused by the steam from the ice that is pushing into the liquid lava and inflating it. And that can also happen in natural eruptions from gases like sulfur dioxide and carbon dioxide. Such gases can inflate the liquid lava and create lava caves inside a lava field. So here we just recreated that. Instead of using toxic gases, we are just using the steam of the ice. And you see that the surface is very quickly transformed into this beautiful, black, shiny, volcanic glass. So now this is already completely solid. And if we go a little bit higher, we also have a very solid surface forming here as well, but inside this channel, the lava is still quite liquid. So now we can go underneath the lava channel and we can begin to lift it up. And you see it holds together, but it's gonna start to open up a little bit and we'll see the liquid lava pour out. And you see it's not as liquid as when it enters the room because the lava has been cooling down. And as it cools, it gradually becomes thicker and more viscous before it solidifies completely. So now we have a much more thick and viscous type of lava. Almost like mozzarella cheese. Stringy. And also we are now able to hear the sound of the lava cooling down. If you listen to it, you will hear it's making these crackling sounds and popping sounds. What's happening now as the lava is cooling, it also begins to take up less and less volume. So all of this lava is currently shrinking. And as it shrinks, it also changes from a liquid to a solid, so it begins to pressurize itself, and then it starts to fracture and break into smaller pieces. So that's the sounds that we are hearing from the lava. It's cooling, shrinking, and breaking.